Hi, so let's have a look at this question. The text tells us that we've got two congruent parallelograms, ABEF, CBED, and it also tells us AB equals BC equals X. So I'll just put that on the diagram. And the other information it tells us is that P is on AF and Q is on CD, such that BP equals BQ equals 10 centimeters. So I'll draw that on as well. So I've got these lines here. Well, it gives us that angle ABC is 30 degrees, and that we need to prove that cos PBQ equals this expression. So yeah, it took me about 5 minutes looking at this before I realised a way of doing it. One thing I did try, using some geometry properties, so this would also be 30 degrees, it's parallelogram. So FE is parallel with AB, similarly with BC and ED. And from that I could work out this angle here, which would be 330, and that this was then, I think it was 165, and I thought, well, maybe I can use sine rule, which is absolutely fine, except I have no idea off the top of my head what sine 165 degrees is, so this isn't going to help me. So I aborted that as an idea and had another look at it. The other thing occurred to me is that we know that AF and CD are parallel. So we know that the distance AC and the distance PQ are the same, which gives us some way of relating a couple of triangles. So the first triangle probably look at here is ABC, which is this one here. Let's move it across to one side. I'll just scribble ABC on it so we can see. What can we do with this? Well, I'm going to use the cosine rule, and from this I know that AC squared equals AB squared plus BC squared. Well, AB and BC are both x, so AB squared is x squared, BC squared is also x squared, so I can leave that like that. And then it's going to be 2AB BC, so that's also going to be x squared. And then cos of 30 degrees. So we know that cos of 30 degrees is root 3 over 2, so that's one of the trig properties that you were expected to remember. Let's collect some terms. I get 2x squared, so I can have 1 minus cos 30 degrees. Well, cos 30 degrees is root 3 over 2. 2x squared, this would be 1 is the same as 2 over 2, so I can have a common denominator here. This will cancel. So I get AC squared equals x squared, 2 minus root 3. It's beginning to look like something we're looking for. So I have another triangle here, which is PBQ triangle. So let's just move that across and write on the letters. So we've got PBQ, and we know that this is 10 and this is 10. So I'm going to use the cosine rule again for a second time. So we know that PQ squared equals PB squared, which is 100, plus BQ squared, which is also another 100, minus 2 times PB times BQ, so that's 200, cos PBQ. So this angle here. And this is going to be 200. 1 minus cos BBQ. So since we know that PQ squared equals AC squared, parallelograms, just to say that that's why I've used it. And this leads to x squared, 2 minus root 3, equals 200. 1 minus cos PBQ. And then this can be rearranged. I'm going to divide both sides by 200. And we're very, very close to the answer there. If I add cos PBQ to both sides, I'm going to have cos PBQ over here equals 1 minus, just swap those round, x squared, as required. I hope you managed to follow through on that. If you've got any questions, put them in the comments. Thank you very much for watching.